This is a Math 2 summary video for the lesson titled ET on the Run. This lesson is a Solidify Understanding task. The purpose of this task is to provide students with a context for adding linear and quadratic functions and to study what happens when you combine the two function types. In this lesson, students will create multiple representations of both linear and quadratic functions and identify the type of function by examining the rate of change. In the first part of this lesson, we need to find an explicit equation that relates the image number and the number of white squares in the eyes, arms, and legs of each figure. When writing an explicit equation, I tried to relate the term number to each figure. I noticed that there are 6 groups of 1 plus 8 other white squares in the first figure, 6 groups of 2 plus 8 other white squares in the second figure, and 6 groups of 3 plus 8 other white squares in the third figure. This means that there are 6 groups of n plus 8 white squares in each figure. I could also create a table and count how many white blocks are in each figure. The first image has 14 white squares. The second has 20, and the third has 26. I noticed that the number of white blocks increases by 6 each time the image number goes up by 1. This can help me find that in image 4, there will be 32 white squares, and it can help me write the explicit equation in point-slope form. To create the equation for the body of the figure, I look at the dimensions of each rectangle. In the first figure, I can see the dimensions of the rectangle are 2 by 3. In the second figure, the dimensions are 3 by 4. When writing the explicit equation, I want to relate the term number, or in this case, image number, to the dimensions of the rectangle. I can see that the height of the figure is 1 more than the image number, and the width is 2 more than the image number. When multiplying the dimensions of the rectangle, it tells me how many shaded squares are in each image. This means that the equation that relates the image number and the number of shaded squares is g of n equals the quantity n plus 1 times the quantity n plus 2. In the table, we can fill in the values that we have and find the pattern of change. Since the first difference creates a linear pattern, we know that this is a quadratic function and that there would be 30 shaded squares in the fourth image. To create an equation that models the total number of squares in each figure, we can add our two functions together. In the table, we can add the number of white squares plus the number of shaded squares. Adding the functions also works for the graphs in the equations. For example, to create our new equation, we just need to add f of n and g of n. When we look at the pattern of change in the table, we can see that it's linear, which means that this function is quadratic. We can use this pattern of change to find the total number of squares in the fifth image of the pattern. So to summarize, in this lesson, we have been reminded that linear functions have a constant rate of change, and quadratic functions have a linear rate of change. Or in other words, quadratics have a linear first difference and a constant second difference. When we added a linear and quadratic function together, we built another quadratic function. So the question that remains is, will this always happen? When you add a linear and quadratic function, will the sum always be quadratic?